Welcome to Syntax. Today we have Matt Brown on. He is a YouTuber and security consultant who specializes in pen testing IoT hardware. He has a YouTube channel that's filled with fascinating videos. So, for example, he found dozens of unsecured police license plate cameras, and they had a video feed. It had a stream of all of the data, which include the license plates, the car make and model, and the GPS coordinates. He's hacked a smart grill and extracted the firmware from that, and he's dove into the network activity of dozens of cheap Chinese cameras. And recently he let Claude Code rip on one of them, which was really interesting. So we've had him on today to talk about how all of this hardware hacking stuff works, the legality of it, and hopefully a few interesting stories. Welcome, Matt. Thanks for coming on.
Thank you for having me.
Yeah. So I've been watching your YouTube channel for, I don't know, probably for about a year now. I'm not sure how I stumbled upon it, but you have these really good breakdowns of how you can take a piece of hardware and then just dig into how it works, or find some pieces of interesting pieces that you may not necessarily know, or buying something that's from like a different industry, like the police license plate readers. And then you could just buy one yourself and then just dig into it, and you find all the API endpoints, and then you realize, oh, this is maybe not as secure as we thought it would be. So like, how do you even get into all of this stuff?
That's a great question. I guess the chief kind of hacker mentality of curiosity and letting that lead you in the discovery of information and knowledge has always been a thing that I've done since my youth. So back in my high school and college days, messing around with computers at my school, things like that. I've always been interested in going to thrift stores. Back when I was in high school, I would go to Goodwill, which is a U.S.-based thrift store. I don't know if they have them outside the United States, but
we have them in Canada.
Oh, sweet. So I would just go buy used electronics and take them apart and see if I could take them apart, put them back together, see how they worked. And that led me deeper and deeper down the hardware hacking rabbit hole, where now on my channel, I like to just buy used devices, take them apart, and usually I'm after two things. I'm usually, like you said, interested in kind of revealing knowledge that might have security applications in the software. The funny thing is, there are people that are like deep hardware silicon hardware security researchers, and that's actually not really my thing. Usually hardware hacking is like a means to an end to hack on software or hack on APIs, to reveal, APIs that I wouldn't have known existed maybe unless I dug into a piece of hardware.
Okay. That's really interesting to me, because in the web development world, we love spelunking into the dev tools. You open up the network tab and you see what's going on, or we have an app on the desktop called Proxyman, and that will allow you to monitor traffic that's coming in and out of it. And some of us dip into maybe even Wireshark, where you get a little bit past just HTTP traffic and into some of the lower level stuff. But once it ends on something running on your machine, or maybe something running on your phone, and you proxy your phone's traffic through your computer, that's kind of where it ends for me, of dipping into it. And there's always these you get a camera, or you get this thing that you connects to your Wi-Fi, and I'm always curious, man, what are the API calls happening there? And it's kind of tricky. So let's say you pick up a piece of hardware. What are your first steps for sort of breaking that down, trying to find out what the APIs are?
Yeah, so if I'm looking at kind of your standard IoT device that is going to make calls out to some backend server on the internet, most of the time that's going to be wrapped in TLS, right? So just opening it up in Wireshark, I'm going to get a host name and nothing more. I'm not going to get any endpoint information. I'm not going to because what we want, right, is we want it to be like the network tab in DevTools. We want to actually see the requests and the responses, because then as security, from a security or maybe just a tinkering perspective, maybe you want to write your own application that interacts with the backend, right? Some kind of a third-party thing. There's all sorts of applications of this hardware hacking work. And so there's a couple of avenues. One is if we can get a root shell on that device, if we can gain control over the device, then we could potentially put our own CA certificate in the trust store of that device. Kind of like if you've ever used Burp Suite or any of these proxying tools to look at web traffic from your web browser, you have to go in either to your computer's trust store or the browsers. Like Firefox has its own independent trust store. Chrome uses the OSs. And you have to add the proxy certificate to allow it to terminate that SSL, that TLS communications.
So that's why when like you get like a laptop from your employer and they install their own certificate, they're able to, even though the website you're going to may be HTTPS, they're still able to see every request that's coming through there because they literally are putting a secured certificate in the chain, right?
That's exactly right.
Yeah.
So we can effectively do the same thing in the hardware world if we obtain a root shell, or we're able to modify that firmware somehow, modify the running device, and put our cert into the trust store. And I say trust store, we have to do some reverse engineering. Sometimes it's like a common Debian system where it's going to be in etc SSL certificates or something like that. That's really common. Sometimes it'll be super hard coded into a binary that you kind of have to do some reversing and modifying of the system to figure out how to put yourself in that chain of trust. But once we put ourselves in that chain of trust, then we can use a transparent or an intercepting proxy, which Burp Suite and Kaido, they do have a mode where you can enable that and allow it to proxy your traffic. Now, then you have to do some network shenanigans, maybe with IP tables or something with your router to convince your device to route its traffic through this system that has a transparent proxy. But at that point, we are able to see all the contents of that HTTP communication.
And if you want to see all of the errors in your application, you'll want to check out Sentry at sentry.io/syntax. You don't want a production application out there that, well, you have no visibility into in case something is blowing up and you might not even know it. So head on over to sentry.io/syntax. Again, we've been using this tool for a long time and it totally rules. All right.
And like, what's usually running on these devices? You mentioned like Debian. Like, are a lot of these things just running like Linux on them, or does it depend?
Yeah, so in the IoT world, there's kind of two categories of devices. There are more traditional Linux-based devices, and then there are microcontrollers. And so you'll often see these used in different applications. If you need like a low-power application, if it's a battery-powered device. Now, these lines can blur, of course, but generally speaking, if you have low-power, battery-powered device, those are oftentimes going to be microcontrollers, which are a whole nother game in terms of how to do that firmware modification.
Like an ESP32 or like one of those like Raspberry Pi Picos or something like that.
Exactly. Yeah, and the Raspberry Pi world is a great distinction. So Raspberry Pi Pico, microcontroller, regular traditional Raspberry Pi is going to be a microprocessor that runs Linux,
a mini Linux
kind
computer,
of operating system. Exactly. So in the Linux case, that's what you're going to find most of the time. If you're targeting routers, IP cameras, most of the time those are going to be Linux. Now that is changing because people like battery-powered cameras. They like lighter weight devices that don't need to be plugged in, and so you are seeing some advancements in microcontrollers in that space. For Linux devices, it's oftentimes going to be just a very kind of custom, like I call it like an SDK, where a chip provider will provide an entire build system that will include a kernel and all the root file system necessary to boot Linux. And then on top of that, a device manufacturer will build all their custom business logic in the form of some kind of a daemon that will run and that will communicate out to the cloud.
And what language is that stuff written in typically?
Mostly it's C. You'll see some C++. In very odd cases, you'll see some higher level languages like Python being used, but it's mostly a bunch of C code that is ripe for finding, command injection, buffer overflow type vulnerabilities that are kind of commonly plague those languages. Yeah.
Okay. So you get something, and like, how do you even get root access to that thing in the first place? So you plug it in via USB. Often it will just like go into the mode where it just like mounts as a USB drive or acts as a camera. How do you get the lower level, which is access to like the firmware that's running on this thing?
Yeah, so typically what I'm going to do is I'm going to open up the device, and the first thing I'm going to look for is the UART console header or debug pins on that device. It's typically going to be a 4-pin header or connector
Yeah.
that might not even be populated, right? They might, for their debug version or their kind of development version of that device, they might actually have a header populated. Whereas in production, they might try to like take that component out just to save a little bit on their bill of materials cost for the device. But you're going to look for that connector, and that's where kind of in my videos I talk about how there are these USB to UART adapters, and those are going to be set to a certain voltage. 3.3 volts is like the most common one you find out there. And when you connect up to the TX and the RX line, so it's just an asynchronous physical communication. My analogy I like to talk about is it's kind of like a physical UDP socket, right? It's you can send and receive data across these physical wires, and then on the device that can be connected up to a couple different things. So on a Linux device, that's typically going to be connected to the console. And so if you are connected properly and you power on your device, you're going to start to see the bootloader logs roll by. And maybe you can like smash a key and interrupt that boot process. If we let it boot up fully, maybe they're dumb enough to just leave a logged in root shell, right?
Yeah.
They don't even make you log in, or maybe there is a login prompt, right? And this is where we start to rabbit hole into different ways to turn the situation into that root shell.
Okay.
So there's a lot of different tricks you can do, but if you have that console access, you can oftentimes turn it into a root shell.
That's so fascinating to me, because like you open up any electronics, you're often going to see a couple little dots that'll say TX, RX, and ground, right? And those are your UART connections. And
Yep.
And you can buy on Amazon. You can buy like a $5 little USB converter, where you just attach to those pins. I know there's probably some more advanced like things, but at the very basic, you're trying to connect those 3 wires to a USB, and then you can directly connect to that from your computer. And then when you turn it on, the way I know about this is because I did a putting JavaScript on my Roomba video. And if anyone's like looking to get into having fun, the old crappy Roombas are like $6 at a thrift store, and there is full documentation, and there's a pin header right on the top of the Roomba. You don't even have to open it up, and you can connect directly to it. And then when it boots up, you can see all of the logs, and then you can just start sending and receiving commands from it. And there's libraries out there that will help you both send what the commands are, as well as receive things like the battery temperature and the how fast something is driving, all that interesting stuff.
Oh, that's so cool.
Yeah. But so like I'm curious, like that's like that was really well documented for me, right? Like Roomba wants you to hack them, which is kind of a bummer. Now Roomba's filing for bankruptcy. But like, what do you do to figure out what these commands are when someone doesn't want you to hack with it?
Yeah, that's a great question, and that kind of leads into the second activity. So if the first activity is like finding that UART console, and if it doesn't immediately give you what you want, right? It doesn't just like drop you into a Linux shell. Maybe it leaves you at a login prompt, and you're like, okay, how would I guess what the the username and password is? Kind of the second activity then is firmware extraction in terms of hardware hacking. Again, always for that purpose of hacking the software. So this is like where we are able to, with a hot air gun I've got over on the bench here, able to desolder a chip. Sometimes you can read the chips in circuit, meaning you can leave it attached to the board, and you can attach a universal, like a programmer, a firmware reader to a chip. Some chips are just not able to be attached to that way based on the physical layout of the chip. And so that's why I prefer to desolder things. Also, you can run into some issues where if your in-circuit programmer reader can like inject power, it can basically power the board and cause it to do a bunch of undefined things. So usually I'll
let the smoke out. Does that happen sometime?
It can, or it can just like mess with your firmware read is what's probably more likely to happen.
I see. Okay.
Because then you'll like power up the CPU or the MCU, and it will try to start talking to the flash chip too to read and write from it, while your programmer is also trying to interact with it, and so you're like both like arguing over who has control over the flash chip.
Oh, I see.
Yeah.
Okay.
So once you remove that flash chip, you're gonna put it into a programmer, and then obviously you need to have a bunch of different kind of adapters to fit the different kinds of chips. But once we do that, and once we read that software off, you're usually left with a binary blob that is the entire contents of that flash chip. And so usually on a Linux-based device, that is going to contain multiple partitions, multiple file systems. And so that's when our handy tools like binwalk are going to come in handy for searching through that binary blob to extract out well-known file systems. So you'll see things, especially on more heavy Linux systems or like Android-based devices, you'll see like ext4 file systems. There are also a lot of file systems that are made specifically for embedded devices like SquashFS. There's a whole number of file systems that you'll never see outside of kind of the IoT space.
But these things are like well known. That's what was so interesting to me about this, is that like just like us web developers, we're reaching for like React and Node and all of these like well-known things. People who are making hardware are also reaching for well-known things. Often they'll take a chip off the shelf that is like 80% of the way there. And because those things are well-known, then they are also a little bit easier to decrypt with tools like binwalk. Is that true?
That is true. Yeah. So binwalk, usually if you the common flag you pass it is -e, which is just, hey, is the extraction flag. Like say, hey, go through this file and extract out all of the well-known file systems. And so if that works, and there's a whole bunch of caveats of, sometimes a manufacturer will try to be cute and like slightly modify a file system specification, but most of the time they don't do that. And you're left with the contents of like maybe the root file system and maybe another partition. So most of the time on these IoT devices, there'll be multiple partitions, and the root file system will be read-only, kind of as a reliability mechanism, right? To keep creep and errors from making the system unbootable. And then you'll have data stored in another partition, and those are all of the things that you need to then go start searching through the file system for binaries you might want to throw into a reverse engineering tool, or say the Etsy shadow file to grab password hashes out of, and then you can try to crack those password hashes to go back to your UART console to attempt to log in.
Okay. Man, this is so fascinating to me. Sorry, Scott, I'm not letting you. No, I haven't let Scott talk at all.
I don't do any of this stuff. So Wes is the hardware hacker on this show. So I'm just kind of like listening and soaking it in. So no, I appreciate your insight, Wes.
All right. Oh, good. Oh, so like what's the next step then? So like once you've dumped this firmware and you've used binwalk to sort of look through it, like what are you then looking for?
Yeah, so like I said, if my goal is still like, if I haven't accomplished that root shell goal yet, then I might look for things like the shadow file, and then I might grab those password hashes, those Linux password hashes, and throw them into Hashcat, use my GPU to try to crack those passwords. And so if that's successful, then that gets me in. If that's not successful, there's kind of the next step down the rabbit hole of attempting to modify that firmware image. So if there's a password that I can't crack, but there's a shadow file, maybe I could replace it with a hash that I do know the corresponding password to. And then if I can package all the file systems back up into that binary blob, and then use my programmer to write back to the chip, and then solder the chip back onto the board.
Oh my gosh.
Then it would, assuming there's no kind of secure boot controls, there's no integrity controls on the system, which you're seeing more devices that have those, but some of them, there's still lots out there that don't have those kind of controls.
Can I tell you a story of one time I accidentally did that?
Yeah.
I had bought this was probably like 12 years ago, and I had bought a camera off of, I think AliExpress or Deal Extreme back in then. And it was like the Chinese version of a very popular North American brand. And I was like, I wonder if I can just load the firmware from the North American one onto the Chinese one. So I went on GitHub and I found somebody had dumped the firmware from one of the North American cameras. So I just dumped that on my camera, booted it up, paired it to the North American app, no problem. And all of a sudden I see video from somebody else's camera. And I was like, oh no, like it must have it must have flashed the MAC address or some sort of identifier. And it was like in someone's bedroom. So I unplugged it, and I have never to this day plugged that camera back in again. Cause I was like, I don't know if what I just did was illegal or whatever, but I was just trying to get it added to my own thing. And it started streaming in someone else's video. And I was like, I was almost kind of scared there. And I have never plugged it in again. I think I tossed it a couple of years ago because it was kind of scary, but that's something that could happen, right?
Oh yeah. So that's So going back to how there's commonly like a root file system that's kind of unmodifiable, and then there's the data partition. So what was probably wrapped up in the data partition somewhere is some kind of APIs, tokens, keys that identifiers that corresponded to probably the person who made that repo and the firmware dump, right?
Yeah.
and then you, by flashing that onto your device, you basically cloned the device, right?
Mm-hmm.
And so that is an attack that that could be considered valid, in some cases. Now, obviously, you need like physical access. You need a firmware dump to somebody else's camera. So it's like in a lot of cases that won't be like a security vulnerability, right?
Yeah.
It's like if I give my keys away to somebody else, it's like, okay, yeah, then they can they can access my stuff.
They can enter your house. Yeah. Okay.
Yeah.
Yeah. So with all of this stuff, like, where does that legality border exist?
Ooh.
Yeah, have you ever had the police knock on your door?
No police. I've had some strongly worded emails, but I haven't been sued yet, so that's good. knock on wood here. So generally speaking, my understanding, I'm not a lawyer, by the way, so this is not legal advice. Is if I own the device, right? I'm always very careful when doing security research to like if I'm hitting API, like cloud APIs, that's where I draw a very strict line to. If I want to test, can like one device kind of access the stuff of another device, then I'll buy two devices and I'll create two accounts, right? And I'll try to do those cross-account attacks on myself. Again, not legal advice. That might still be considered an unauthorized test. And then obviously the hardware that's my property when I buy it. There are some United States laws against reverse engineering, but at least today, they still all have carve-outs for what is called good faith security research. So, again, I'm not a lawyer and don't know the specific definition of that term, but I try to do my research in good faith,
Yeah.
and to not to use it maliciously, not to attack other people. And so, at least in the United States, we have the kind of those protections. I obviously don't know about other countries, what the situation is there. Yeah.
All right. So where were we with the process of?
I think, yeah, like what to do with the firmware extraction. So another thing that might be interesting, especially to like kind of like in getting into the web topic, is so the first kind of theoretical IoT device we talked about was where the device reaches out to a cloud server via its APIs. But also a lot of times these devices will have their own embedded web servers on them. They'll have or other network services that can be connected into, right? So maybe there's a mobile application, and let's talk about a video camera, right? So in the video camera use case, you could think of, okay, I want to be able to access my camera remotely. And so when I'm away from my home on the mobile app, that data has to go up through the cloud server. But if I'm in my house, now there's a lot of latency. There's a lot of video latency in that first case. So maybe when I'm in my house, I'm on the same network, I want it to stream directly from phone to camera. And so a lot of video cameras will do this. They'll have a way that it can sense that, and the mobile application can directly connect to a service that's running on the device. And so once I have that firmware, I can usually find the binaries that are hosting those web servers or those custom binary protocols that are running on the device. And the web servers are especially interesting because sometimes you'll see kind of standardized servers that use like CGI, like light HTTPD, which will so light HTTPD will manage kind of the basic web stuff, but then it will make calls to a binary, to like a C program that will actually like execute when you make a web request to certain endpoints. Also, you'll see people roll their own web server and web application all in one binary, which is always fascinating because then they're doing all the raw. They're rolling their own web server many times, and so there's all sorts of potential security issues there. And then the application, the business logic is all implemented all in one binary.
That's exactly what I did with my Roomba. The React.js code, the web server, the WebSocket server, and the like lower level communicate, send bytes to the Roomba. That was all in a single binary. So that's generally not a good idea, you're saying?
No, like, I guess what I'm saying in the IoT world, there's not like, there's some standards, but it hasn't coalesced as much as the traditional web world, I guess, around a certain set of frameworks and standards. There's a lot of different people who had their own ideas about how to implement a web server and or a web application, and it just leads to a lot of security bugs where each case is different. It's not like I can run it's not like I have a security tool that audits like React applications, and then I run that tool, and then I find vulns, like common mistakes people make with that framework. There's not like just oftentimes it requires custom reverse engineering of each web server / web application on each device to really uncover if there's anything that's not being done correctly.
Oh, man. All right. So you have access, you figure out what the API endpoints are. And then like what's your process for trying to replicate what these things are? Do you then bring that to your computer or do you try to like put a custom firmware on the device?
Yeah, that kind of depends. Usually I'll try to extract some of that logic out, right? Like you want to figure out how the authentication is being done, and even that you'll see being done in kind of a multitude of ways. It might be using, mutual TLS authentication with the kind of like client certificate auth, or some kind of API key that's on the device. If I can get that off the device and replicate it in Python or in my own browser, that's something that I like to do a lot. But a lot of times it's just like making little custom Python scripts on my desktop side to emulate the device and its calls, and then I can fiddle with, hey, can, like, I have a device on this account and a device on this account. Can device A access or make API calls as if it was device B?
Okay, I see. Yeah, that's fascinating.
What gets you inspired to look at stuff specifically? Like, how do you pick a project that you're working on? Is it just you see something and you have a question, and like you mentioned, your innate curiosity kind of takes over?
Yeah, I guess. Yeah, I guess it is that curiosity, and I'm always like looking for challenges in new industries, right? So like right now, like this is something I haven't even made a video on yet, but I'm kind of getting interested in drone technology and drone hacking, and so then there's a whole bunch of like skill sets that involves. So I might look for different devices to like help me build a certain skill set, right? So there's been times where I've purposely sought out devices that I think will have a certain kind of microcontroller or a certain component that I want to learn more about. And so I'll kind of try to cherry pick the hardware to teach me something, because honestly, making content, making the videos is one of the best ways that I learn and I get better as a professional by just trying to do something new.
Yeah.
What about doing more like man in the middle detection? So I'm thinking about right now, I've got a fleet of these like 12-volt Fisher Price cars that our kids drive on. And we have one that's called a Wild Thing, where it's kind of like a little wheelchair you sit in, and you have two joysticks. I found it on the side of the road in the trash, and it didn't work. It was erratic. So I replaced the main like motherboard on it with a brand new one, and it still didn't fix it. So I was like, oh, the joysticks themselves have little daughter boards on them, like tiny little boards. And I'm at a point now where I'm like, how do I figure out what the daughter board is sending to the main board? Is that something that you dip into as well? It's not really APIs, it's more lower level. Or I think about like the button to talk to my garage door is not simply just like closing a loop of electricity. It's sending some sort of data. How would I figure out what that data is?
Yeah, that's a great question, and that is stuff that I do. And the tool is going to be a logic analyzer. That's going to help get you insight into those digital communications that are happening, kind of like between different chips on a PCB or between two different PCBs. So so you typically a logic analyzer is what's going to help you, and then connecting up to those lines, right? So if we go back to the case of the UART console, right? That's just digital communications, but there's not yet another end connected to it, right? So sometimes if I'm trying to even debug a UART kind of interface, maybe it has a really weird baud rate, like a symbol rate for how fast it transmits. Sometimes then I have to go back a step. I have to set aside that USB to UART adapter for a second and actually connect up a logic analyzer. So the best way to think about a logic analyzer is if we know what a multimeter is, right? A multimeter measures voltage, right? And a multimeter is slow, right? So it's like I connect it up to like a circuit. It might say, if I connect it up to like a UART, where a digital signal where it's oscillating between 0 volts and 3.3 volts, then a multimeter, it might give you a little fluctuation if there's some data being communicated, but it's going to be really slow.
Yeah.
But a logic analyzer can sample a lot faster and can give you a nice clean kind of a square wave that represents that digital signal. And then go ahead.
Is that what like an oscilloscope is? I see it over your shoulder right now.
So yeah, no, that's a great like thing to put on the spectrum, because on the kind of spectrum of sample rate, multimeter super low, logic analyzer kind of sits in the middle, and then oscilloscope is like super fast sample rate. So it's kind of like figuring out the right tool for the right job, but they're kind of all sampling the DC voltage and giving you kind of a readout of what that situation is. So most of the times to interpret a digital signal, you don't need to go as far as an oscilloscope. Usually a logic analyzer will
and
be
a
sufficient.
logic analyzer will also record it, so you could I could hook it up, hit the button, or like pull the controller back and then go back and look at it and say it sent just like highs and lows. Is that what it's sending?
Yeah, exactly. So the most common one out there that goes with us. So Saley makes a lot of very nice, they're a little more expensive logic analyzers. You can also get little ones for like $10 that are kind of like knockoffs on Amazon, and it will work with their software as well. It's called like Logic 2 is the name of the software. And yeah, it will give you a graph that you can zoom in and out on the signals, and then it will include all of these analyzers, right? So if you're like, okay, I think this is a serial communications, then you can kind of add the analyzer, and it will, let's say if it's like transmitting like just ASCII data back and forth, like a kind of that UART console situation would, you can have it interpret, and you'll see like over a set of 8 bytes, it can put the symbol. It can say, okay, this is the letter A that's being transmitted. If you're interpreting that correctly, and you can, and that's where you can kind of test hypotheses to be like, I think this is a UART signal, and I think the signal rate is this. There's also other protocols that can be used, like, like SPI or I2C. There's these different digital protocols that use one or more wires to communicate a digital signal.
Okay, so GitHub Universe had a badge that was like a little PCB. It has a Raspberry Pi microcontroller on it. And there's a little, I only recently learned it's not I2C, it's I2C, but that's often where you can buy like a microphone or a little display or something that also sends I2C communication. It's like kind of a nice hot plug thing.
Yeah. And so those logic analyzers are what to use when you like you're like, okay, I think it's using one of those well-defined protocols, but I don't know which one it is, right? It's kind of your first step to uncovering that mystery. And then once you do that, then you can use kind of a dedicated tool that speaks whatever the protocol is, like in our USB to UART example. If it's serial communications, that's what UART is, right? It's a form of it's a two-way, serial asynchronous serial communications. So.
And is this what like tuners are doing in cars as well? Because in your car you've got like an OBD port. And there's all kinds of pins on that thing. And then you can get some guy to like tune your Dodge Ram or whatever, right, to roll coal. Is that what they're doing here?
Yeah, and so that's another protocol. More or less, but they're probably going to be, again, using a dedicated tool because they know what protocol it's going to be CAN.
CAN bus, yes.
Yeah. CAN is the protocol that pretty much all automotive stuff uses to communicate. So, your wheel sensor can communicate to the ECU, and all the other components in your car can read the messages of what's going on in the car. And so that's what that ODB2 port is giving you access to. So you could use a logic analyzer, but in that case, pretty much everybody knows, they're like, okay, it's going to be speaking CAN, so we can use a CAN specific tool. The logic analyzer is the generalist tool, and then usually you figure out what language, what protocol those digital communications are using, and then you use a purpose-built tool to kind of hone in on that.
Oh, that's cool. I've always wondered that, because in like the Tesla world, there's all these like aftermarket accessories that will like pop the passenger door open or like recline the passenger or turn the back lights on, and people just add buttons wherever they want, and it's because they're adding this little module somewhere in the CAN stream, and I guess intercepting those requests or sending them down the pipe if they need to.
Yeah.
That's cool. Have you dug into any of the car hacking stuff yet, or is there plenty on your bench to work on?
Yeah. That hasn't been an area of focus yet. Like I said, I'm curious about everything, so it's just a matter of managing that curiosity. And haven't gotten quite into the automotive world yet.
Do you have any like crazy stories of things you've done recently that's kind of fun? Or even just like hardware IRL. Like every time I see like a massage chair or like an arcade claw machine, I'm always trying to hit combinations of buttons or like trying to like reset it. Or the in-screen entertainment systems and the plane, you're always trying to hit the buttons and figure out what that is.
Yeah, I think I had a post on X about that. I was like flying back. I think it was from DEF CON, and like I was able to figure out like I wasn't able to get a full escape back to like the Android, but like most of those in-screen displays are Android. In fact, I like, this is a little bit of context into the industry that I'm most familiar with, but most like security panels at home that have a nice display, not like a super old, like crappy LCD display, but a proper display on them, those are usually running Android as well.
Oh, interesting.
But those in-screen displays, I was able to like enter a game, and then like it would show the home, like the go home button, or the like the button in Android to like access your other running applications, and you could spam that really fast, and like it would escape back to the like just the app selection menu, but it didn't let you escape any farther than that. But, yeah.
Oh, that's so fascinating. I also had a post on X a while ago asking like what these things are built in. We had a couple people from the industry chime in as to like what they're built in, and it was a really interesting read just to get a peer into these, how all of this stuff works, especially on a plane. It's a fairly closed loop system because the shows are on a drive on the plane.
Oh yeah, no. That stuff is super fascinating. Yeah, with hardware, I'm always looking around me in the world for targets. So I'm like that weird person that's like in a coffee shop, and I'm like, oh, they have that brand of security camera running, and. But I think you mentioned my grill video, because that's I had that smart grill for probably like a couple years, and I've always been like, oh man, I should really rip this apart, but I don't want to break my grill. So that was a fun adventure, and that always leads me to like eBay, right? Like eBay is just a great place for me to go find a bunch of weird used industrial technology or consumer technology to always hack on.
So tell us what you did with the grill, though. I think that was pretty interesting.
Yeah, so that was, it was just a fascinating experience, because first, the motivation is like, I use my grill. I don't want to like accidentally brick my grill because I'm like trying to do firmware extraction on it.
Yeah.
And so I went on eBay and I found a replacement computer module that was supposed to work as a drop-in replacement for my grill. And so I went and I started to do the analysis on that, and I was like, this is weird. This like doesn't properly connect out to the internet. And so then I was like, all right, I just need to go do it on my own grill. And so I ripped them off, and I was comparing apples to apples, and it was like a different hardware revision, which was really fascinating. So I don't know if that was like the thing I bought on eBay was someone bought that device, like that device was some kind of a development unit or some kind of a unit that didn't pass QA, and they're like, oh, I'm going to make some money by reselling this on eBay.
I'm always curious about that as well. Is like, how hard is it for people just to create like aftermarket boards for these things? Is that something that happens?
Yeah, well, and then like part of the security world that is not usually the like security flaws that I'm looking for, because these I'm not as concerned about, but there is a lot of anti-cloning work in the security community, and so they are trying to prevent firmware extraction, right? They're trying to, or they're trying to put some piece of the puzzle in a place. Maybe it's in some kind of internal storage inside of the CPU, or it's a microcontroller where they can actually lock the debug connection, and the firmware is like locked inside the microcontroller. And they'll do that to prevent cloners from just reading out the firmware and then producing a compatible unit.
Yeah. It's a hard thing because like part of me, like I have a Sea-Doo that's 20 years old, and you go on AliExpress and buy an entire like computer. It's called an SPI for your Sea-Doo. And for like $80, you can, if you for some reason have blown your 20-year-old computer unit on your Sea-Doo, you can just get a brand new one and slap that thing in. Which is great for like right to repair, but also awful for like someone could steal your Sea-Doo and just slap in a new computer unit, and that thing is untraceable now. It's a tricky area.
It really is, and I've gotten asked those questions before, and like I'm not an expert. I'm really interested in the whole right to repair movement. I actually I would not have started my YouTube channel if it hadn't been for Louis Rossman, actually, for kind of a funny reason. So I hate video editing. I'm not good at it. And so I would like watch his videos, and I'm like, this guy gets a ton of people watching board repair videos unedited, sometimes like an hour-long video. And I was like, okay, so like long-form content, clearly not dead. And attention spans in the hardware/technical domain, there's an interest for that. So that's kind of what led me to start my YouTube channel and make it just a format where it's more or less unedited and long form. So I have a lot to thank Louis for, and
that's good.
He's definitely
great.
Interested in the movement. Yeah.
Although he did start that paperclip movement, which like the worst people that comment on our YouTube channel are all of a paperclip.
Yeah. Oh my God.
Avatar.
Okay, it's so funny because I haven't watched Louis in a while, right? Just because I'm busy with other stuff, and so I would see all these like paper clips in my YouTube comments, and I'm like, what is going on? Are these like, is this like a bot farm?
Yeah, we thought it was the same guy. Yeah.
And I was so confused, and then I was like, oh, and then like I finally like tracked it back. I'm like, oh, this is like a Louis Rossman thing.
All the paper clips, please leave a comment right now. We need to see you.
Yeah.
Anything we haven't hit on that you'd love to cover?
No, this is really cool. I'm just glad to get to chat and share something interesting with your audience.
I got one more question for you, and this entire podcast is very self-serving. I only want you on so I can ask you questions directly without having to pay for your time. No, I'm just joking. But so for Christmas, we're getting our kids laser tag, and as far as I understand, that's RF. Like it sends an RF signal, and I was thinking like, I want to build a nuke that like I want to build some device where I hit a button and it does RF in every direction and just like boom, gets all the kids and they're all dead. How fun would that be? Like what would even be my first step to building something like that?
Yeah, so this is something that this is a domain that I've recently started to produce some videos on. So that is going to be kind of some radio protocol or reverse engineering, and so a software defined radio, an SDR, is probably going to be step one. Also, the thing is, if it's RF, you can do a lot of open source intelligence gathering through the FCC. So the FCC website, and there's like a third party site, I think it's like fccid.io, that just like scrapes the FCC website.
Oh, I love it. You can see internal photos of everything.
Exactly. Well, and the other thing they'll document on there is the frequency, the radio frequencies that are being used. And that saves you a lot of like scanning around with your SDR. If you know what it's transmitting on, then you can listen. And you're going to need now to actually do the replay attack part of it. you're going to need a radio that can transmit. So the simple RTL SDR that everyone starts with, which is great, those can only receive. They can't transmit signals. And so you're going to need something like a hack RF maybe. And so the hack RF even has really simple programs that will record a signal and try to replay it. So assuming that there's not some super advanced security going on with the laser tag system. If you can just capture a signal, right, like record and then shoot like shoot the gun at the antenna and then record that signal and then try to replay it and see if it has the effect that you're looking for. Yeah.
Man, I think I have something like that. It's either RF or IR. I bought it I think Scott might have done this as well. We have like these like little AC units that don't have like a Wi-Fi chip in them. Yeah. But you can just like point the remote at it and train it, right? I should look into that.
Yeah, I actually got one for my
laser
projector
tag
screen.
Be?
Oh, that'd be awesome.
Yeah. Wes hacking to cheat at laser tag with his kids is
definitely is. And like there's no chance it's like encrypted, is it?
I highly doubt it. Okay. Now what might happen is like each gun might have its own like a part of the signal that's different. If it has any kind of like scoring system, right? Because then you need to know who shot who. And so there might be something that is encoded. I doubt it's encrypted, but there might be some part of the communications that is identifying that's like unique to each gun. But maybe you don't care about that if you're wanting to nuke. Well, then you should do it with your gun because you probably can't, in the system, you probably can't shoot yourself. And so you would be immune if you captured your own gun's signal.
Yeah, you got to filter it.
Sent out the nuke. Yeah.
Oh, man. I think the first thing that ever got me interested in this is years ago, somebody figured out that you can take this like kid's diary from the 90s. It was called the like I Am Me or something like that. It was like this little thing and it had an RF transceiver because you could go between them. But somebody figured out that you can just make it go on loop and send every garage door code out. And this was before garage doors had like rolling codes. So this was like 30-year-old garage doors would just open, which is at our cottage. We have one, it just randomly opens and we haven't pinned it down as to what it is, but it's somebody's key fob for their like Dodge Caravan or something just causes our garage door to open.
Yeah, that's Sammy Kamkar, his work, and he's got a DEF CON talk that I highly recommend any of his stuff. Yeah,
I want to go to DEF CON.
He's done some crazy stuff now. So he's getting into laser, using lasers to transmit sound, and he had a project where he could make an Amazon Alexa unit receive audio with a laser through a window. So he could transmit audio through a window, like if it was in somebody's house, like to the Amazon Alexa, and it would the vibrations, like the signal that it's
like an unmodified Alexa. It would just the vibrations would play.
Yeah.
Oh, that's terrifying. Holy hell.
Yeah.
Oh,
yeah,
man,
he's getting really deep into laser technology now. He's got some like homebrew like laser technology that's like, you gotta wear proper eye protection with all that.
So my last question is IoT stuff. Do you have it any that the classic thing is like I keep my IoT next to my bed with a gun. Do you run any smart home stuff after all you've seen here?
I do. I'm maybe not as doomsday as like most people about it. I've got, I don't know, like I'm just kind of a network nerd anyway. So I do have like networks, some not overly like paranoid, but I do have some network segmentation that I keep, some devices on a different network. And so, yeah, and it's just a matter about, choosing what your risk profile is. I have some devices. I don't have a lot of devices. So it's kind of a compromise in the middle. And obviously I'm always playing around with things in my kind of like test lab here. So I've always got some weird traffic going out of my network.
Matt, that was really enlightening for me personally, considering I don't get my hands dirty with most of this stuff. So I really, really enjoyed hearing all of this. So now is the part of the show where we get into sick picks, which is something that you're just enjoying in life right now. It could be anything from a podcast, a YouTube channel, product, whatever. Is there anything that you're just really feeling right now?
Yeah, so I totally forgot to tell you about this. Usually we have like a whole document we send ahead, but I did it a different way this time.
No. This is really good. So kind of my side interest is has been business lately. So I've been, running my side business, and I've been just getting more interested in how to run a business effectively. So reading books like Key Person of Influence by Daniel Priestley. Just some general business books to kind of up my game in that area. Funny enough, my undergrad is kind of in business, but it was because like management information systems, like my IT degree was in the College of Business at my college. So
that's exactly what I went to school for. I went to school
nice.
for business technology management, which is exactly like not enough coding, but more on the business side of things. But
it was really because I didn't want to take Calc 3 and like all in physics. Why I chickened out of CS, but that's another story.
Oh, that's great. I've never read that one. Key Person of Influence. I can check that out.
Yeah, and it really like I really like that book because it talks about how you can use your I'll never call myself an influencer or whatever, but it talks about how you can use your public presence, your content to build a business that kind of syncs with the rest of your life. And so the cool thing for me is I feel like it kind of follows the journey that I've gone on over the past 2 years, because I made my YouTube channel. When I started my YouTube channel, I was like, if over the lifetime of the channel I get 10,000 subs, I can be mission accomplished. And obviously it rocketed past that. And so that caused me to just get reached out to by businesses to be like, hey, can you do some consulting for us? And so the business just kind of grew out of the content. And so we're just gonna see where that goes.
That's awesome. How long have you been doing your YouTube?
About 2 years now. So,
holy, and you're almost at 200K subscribers. That's amazing.
Yeah. It's been a wild ride.
Yeah. Wow. Well, congrats. Thank you so much for your time today. And
whoa.
Sorry. Never mind. Go ahead, Scott.
Also, the last thing is shamelessly plugging. So is there anything you would love to plug to our audience to make them aware? So we'll link up your YouTube channel. It's a fantastic subscribe. Anything else you want to plug?
Yeah, just if anyone is in the need for hardware pen testing, that's like the one thing that I do at my business. And so brownfinesecurity.com is where you can find info on that.
Nice. Sick.
Right on. And his YouTube is just Matt Brown. It's MattBrwn. If you're going to YouTube as well.
Yeah.
You can click the link in the show notes, but if you're just typing it in, you'll find it in there. Cool. Well, thanks again for all your time. This is super interesting. I appreciate all your time.
Thank you. It's been a great time.
Thanks,
Peace.
Matt.